All right, so we will start with something very practical. First, let's thank Foo Café for hosting us. Thanks, Foo Café. So we have been doing organizing of DevOps Malmo group for like 5 years, and we have been doing this all together with Foo Café. So far, it's going really pretty and really nice. So if you are a company that has a bunch of money and want to sponsor Foo Café, please do so. And if you are a company where you have nice speakers and you want to speak about some technology, so please contact us. It's as easy as just Google DevOps Malmo GitHub. And what we do is basically we created meetup group where it's GitOps meetup, where you just create pull requests to our GitHub page and the rest is organized for you. So that's what is all about the group. So we take all the complexity from you, the organizing, promotions and etc. All you need to do is focus on your talk. Okay? So if you have any idea or online people, I think there is like 1 million people live watching us. So from out of this 1 million people, if anyone can come up with some nice ideas, please do so. And another practical question will be, because I'm going to take some pictures and I will post it in social media. And social media is like meetup.com, LinkedIn, Twitter, and etc. So if you do not want to be in social media, please raise your hand. So I will put in front of your face some celebrity face. So no, that's not the case, but I will just remember. Is there anyone who says, I don't want to be in social media? Magnus, you cannot say it because you are going to be live streamed. So all right, that's good. So we keep in mind. And so thank you everyone for coming. And if you have any bright ideas about how we improve the group or what else we can do better, so feel free to reach out me. I'm available in almost all social medias, and you can send me even a radio signal. So I accept any communications. Okay, so just try to contact me. And that being said, I want to introduce Magnus, who is going to do today talks about Podman. Please, Magnus. And I think the only person who knows what he's speaking so far about Podman is Magnus, and since I trust him a lot. And then another practical question, another practical thing. So if you are going to ask question, raise your hand, and you are going to talk to microphone. So make sure that you keep it like this close, because we have people online, so they can also hear your question. All right? Good. So that being said, the stage is yours.
Super. All right. Testing 1, 2. Yeah. Hope that's audible. Right. Hi, guys. So I'm Magnus Glatz. I'm a principal solution architect at Red Hat, and that is a subject matter expert of technologies who attends events like this. Cool. So this is going to be about Podman. So we already know that Docker is dead in the land of Kubernetes since long. But it's kind of clinged to the developer laptops. So I'll show you what you can do about that. So first, I guess, a bit on the kind of historic part of container technology and how it's been kind of developing and such. And you probably remember, if you were in that kind of field of technology, that it kind of started with Docker, right? But this was kind of, well, I would argue maybe that talking about container technology, I mean, started before Docker, but, right. Some people would say, no, it was Sun Microsystems that kind of, were doing it first. But I think that kind of worked differently, not really comparable. And then we had Alex containers and anyways, but it started getting really popular anyways as the Docker Inc. Kind of started fielding their technology, and it became this kind of was really a good fit with the DevOps way of developing software. And Docker, they had their own orchestration engine, Docker Swarm, right? When Kubernetes started to become a thing, well, you know how the story goes, Google still has this internal kind of orchestration system for their IT. Borg, I think it's called. They still use that. The open source version of that kind of was Kubernetes. And we realized, well, early, like day 0, that this is going to be something significant. So we kind of jumped up on that train. So Red Hat has been we are leading about half of the special interest groups, work groups in Kubernetes. We're deep in Kubernetes, except for Google, probably the ones that does the most. But you know what containers are, right? What are containers? Tell me. It's a tarball, yes. What else is it? It's a jail.
Rooted environment with namespaces.
Yes, yeah. It's just a, well, I would say you're making it complicated. I would say it's just a process in Linux. So from the kind of kernel perspective, there is no such thing as a container. There is only processes running in various different namespaces, and all processes exists in different namespaces in Linux, right? So at the time as Kubernetes was introduced, then we were kind of, well, we had a bunch of, you know, really clever Linux people at Red Hat, and they were kind of bothered by this fact that there was a daemon running, needed somehow to kind of orchestrate the starting of processes in Linux. Just felt, you know, insecure, for example, waste of resources and a bunch of other things. What kind of built the background for this was that, so as Docker had their own orchestration engine, actually, they kind of didn't care about Kubernetes for quite some time, and that meant that they broke Kubernetes quite often, just, you know, developing their runtime, and then, you know, Kubernetes interface to Docker would break like constantly. And this was kind of annoying people in the Kubernetes community, like, now it's broken again. They don't care, kind of. And then came a company called CRI-O, and they have built their own container format called Rocket. And they came with all these patches to Kubernetes and said, hi, we would like you to support our container also. Massive amounts of patches. And that kind of became the I don't know, where you say drop that broke the camel's back or something like that. And then the Kubernetes project was like, oh, just, okay, this is how it's going to be. We're going to create this interface, the Kubernetes runtime interface, and everyone is going to abide by this interface. And if you don't, well, screw you, basically. And around this time, we had started this kind of standardization project for containers called the Open Container Initiative, OCI. You might heard of it. So in this project, we tried to standardize the kind of look and feel of containers, because we didn't want to kind of replay what we did in virtual machines. You know, virtual machines where you have an image in a format and then that doesn't work anywhere else than for this specific hypervisor. We didn't want to have that. We wanted to have portability. So we put a lot of effort into the OCI project to kind of create this. And as this was starting to get off the ground, all these things with Kubernetes was kind of happening, and then it just made sense to create this kind of new container runtime. That was just this religious implementation of the Kubernetes runtime interface. That just would work. Yeah, and then not some years later, you know, Kubernetes was just done with Docker. It wasn't doing anything nice for them, so they dropped the support for that. So that's a bit of background. But then on the kind of if you don't have Kubernetes and you still want to run like OCI compatible containers, the question is then, what kind of tools do you use if you don't have all these things? And the answer to that is, for example, the container tools out of the container project, which is to the back of me here. And that's what we're going to talk about today, or talk. I will avoid talking much more, and I will just like show you how it works. So some advantages of Podman. So the engineering lead for this at Red Hat, so these are Red Hat-led open source projects, is Dan Walsh. You might know him from being the inventor of SE Linux. And he's really focused on security. And one of the things, first things that he kind of took upon himself to resolve was the fact that there was so much root usage in running containers, and he managed to solve that. I'm going to show you how this is resolved, and how you can now develop containers and run containers without one little teensy bit of root. So that makes everything more secure, and because Dan Walsh, this is all very neatly integrated with security features like SE Linux in the kernel. Right. Okay, I think I'll just switch to a terminal. This will probably not work. Sorry, we'll do like this. There? There? Okay, yeah. All right, so this is my laptop. It runs Fedora 37, and I like Fedora. I like the kind of latest cutting edge of open source, and that's a place where you can get that. Cool. A lot of kind of maintainers are also using it, so it makes it easy for me. So let's start and build some containers, I think. So we'll start with some basic stuff. So you know that sometimes it's called a Docker file. So yeah, it doesn't have to be that in the world of these tools. You can call it container file, and then but it looks the same. So here's a simple container. So this uses a free base image that we create, which is called universal base image, which is created because containers are just processes in Linux, which means that you have a lot of integration between the process and the running kernel and things like this. So keeping like operating system and containers and stuff like that in sync makes a lot of sense. And a lot of people are not necessarily just running rel. They might run a rel derivative of some sort. And then we recognize that they should probably be able to have a base container without having to kind of build that themselves. So this is just freely available stuff out of our repository. Don't have to be a paying customer to use this. Cool. All right. So we have the podman command, and just some basic stuff this does. So in the beginning, when people were still having Docker installed on their systems, which I have not had for a couple of years now, then they used to do a symlink from like Docker to Podman in order to not break their build systems and stuff like that. You can still do that if you like, and don't want to kind of refactor away the last traces of Docker. And you'll see that the kind of commands available here, they are kind of one-to-one. There are some stupid things which doesn't necessarily work the same, like if you're doing containers, like Docker containers in containers and stuff like that. Works a little different. You can still do that if you somehow have to. But anyways, okay. So yeah, we have our container file, and yeah, let's build a container then. Build, and we'll call it something. HTTP UBI 8. Bloop. So pulls the UBI container, and we can see as a part of the kind of installation layer here, we're installing Apache web server and then exposing that port. So like I said, this is all free stuff, so anyone has access to the UBI repository, so you can all install all the stuff available there. Cool, that's done. Podman images, and where's our stuff here? Cool. So here's it built. So let's deploy something then out of this. It's just latest. Podman run name UBI 8. Demonize it and do a port forwarding. Bloop. It's running. See if it actually is running. Yes, it is. Cool. Right. So notice that, yeah, I'm not root. I'm this, unprivileged user when I'm doing all of this, and there are no parts needing root in order to, do this. So I think that's neat. Right. So let's build something else. Let's do something more maybe complicated. So there are some container base images that doesn't contain any, like package manager, for example. And if you need to you still need to maybe use a package manager because, there's dependency hell that you don't want to resolve by yourself by, copying files and stuff like that, then we can use Builda. So the challenge with this is, basically Builda is going to help us by creating a root file system, which what we are calling the base image kind of structure that you will see in a container. And then we'll make that available locally to us, and then we can kind of copy stuff into that root file system, and then we can make a container out of that. So that is our other tool. But that has a little challenge, which is that mounting this kind of root file systems, that is a privileged thing. So how do we solve that? Namespaces. We will lie. The right the right answer is we will lie and cheat using namespaces. Yes. So we will create a namespace in which it seems like we are root. And then we will do our stuff inside of that namespace instead. Cool. Makes sense? So here instead I have this build script. So here you can see that I'm using builda here I'm fetching a base container, the UBI micro container, which is doesn't have a package manager. Actually, I could show that to you. It's a bit neat, I think. Sorry, just. Beep, 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 beep. Huh? Yeah, this will be UBI 9. Where are you? Micro? There. Cool. So it's pretty small. It's 7.3 megabytes compressed. And that is without doing, I mean, I'm a bit religious here, you'll have to understand that. But creating your own standard C library is insanity. You don't have to do that. This is glibc. So you don't have to kind of, wake up sweaty at night thinking that the world is going to catch on fire. Right? But yeah, when you make things this small, you cannot have nice stuff like package managers. So, which means then obviously that we cannot do stuff like this. Right. Okay, cool. So that's why we are using this build script then. Right, so, but a neat little trick, we can use DNF or yum, whatever alias you're using, with an install root command. So that allows us to use a package manager in a root file system that doesn't have a package manager. Cool, neat. Yeah, and here are the privileged tasks which requires root normally. And then we are just going to, like I said, lie and cheat using a namespace. So then we use Podman or builda and share, which just creates this without us having to think much about it. Just creates this kind of, yes.
How does DNF solve the dependency tree here? If it doesn't know what packages it's installing?
Oh, yeah, it does. It does. Oh yeah, right. So the question is, well, how does DNF actually know then how? Oh shit, stepped on my charger. How does it, resolve all the dependencies that we see happening here, where it's installing Apache and its dependencies? Well, that was because here, this. So here we are setting the install root of DNF to the mounted root file system.
So the notion of libc being installed there already is in that root.
There are still RPMs installed here.
Okay.
Yeah, it's there are still all these things, come from the same build process as we use to create Red Hat Enterprise Linux, and CentOS and all these things. Right. Cool. So now we built something. So let's see. What did I call that? Yeah, Foo micro. Cool. Podman build. No, sorry. Run, please. No, that will not. So, take like that. Oh, wait. Oh, the name. Yeah, sorry. Thanks for catching that. UBI 9 micro, we'll call it. Okay. Okay, and there it is. Let's see if we can actually reach it. Yes, it still works. Cool. Okay, but that might not be enough for us. We might want to not kind of build upon others' work, because we think that building a Linux operating system is a really cool thing to do. So then, Builda allows us to build something from absolute scratch. So where we start with just some metadata in a completely empty container, and then we start to, build our operating system, but in all fairness, more or less what it is. Large parts of one at least. So then we just tell Builda from scratch, which means that it initiates this kind of empty root file system, and then we can do stuff with that. So here we could put whatever stuff we want into an absolutely empty space. So because I think it's next time that we will do build your own operating system. So I will just cheat here in this example, which is that, if I install bash and core utils, I will kind of get the minimum kind of set of stuff, which is required to kind of have a base image. So, and I'm using Fedora to do this. Could be, anything I like. And then I go about to kind of install Apache. Right. So do you remember what the command was? Unshare. Yes.
Why unshare?
Because it's logical, you're unsharing it from your namespace and going into another namespace. Actually, I don't know. But I don't know. But I would assume that is what because that's basically what we're doing. We're unsharing the stuff that we have inside of the namespace that we are in. So yeah, makes sense. I will ask Dawn. Cool. So let's see if this works. This demo, so I mean something should break. Right. So we can see that there is some, because We don't have a lot of information going into this, empty place. We have to set some things like, release server and stuff like this. Otherwise, DNF will not know what I'm asking it to do, basically. Yeah. And I'm selecting Fedora 37 because those repositories just happens to be available on my laptop. Yeah. And that's also how it works. Stuff available locally gets passed through, available in your build. Cool. All right. It built something. And here it is. Okay, so let's try it and run that. We'll call that Scratch. Oh, yes. Yeah. Okay, it was too late. Podman stop. Good. Now we get to show some other stuff. Podman remove. Cool. Now we can redo this in a correct manner. Bloop. Okay. And then we try to reach this. 882. Oh, whoops. Yes, it works again. Neat. Right. So far, zero use of root. Then, so either Podman or Builda, kind of to build your containers. Builda can also understand container files, Docker files, and there is no daemon anywhere on my laptop taking a gig of memory or something like that, which is neat. And all the stuff that's being run here. Like I said, so this integrates to SE Linux. So, of course, I'm running SE Linux on my laptop. I don't want to be laughed at. And here we can see the container T tag label for our process, which is the HTTPD running inside of the containers. Okay, well, what more stuff can we do? Exec. Yeah, of course. Proc command line. Yeah, okay. So our process running in the container. Cool. Yes. What else can we look at? Well, maybe Podman save. For example, if we wanna just HTTPD UBI save it to disk, and then let's compare the different things maybe. UBI micro. No. What did? Ah. Thanks. This is cool. You should come to Red Hat. Already helping. Scratch. Yeah, you know how it is. Okay. So let's compare some sizes here. So micro 170.
Can you take a step to your right?
Oh yeah, yeah, totally, yeah. Scratch is 150. And UBI 8, well, it's not a fair comparison. It would be a little smaller. But still, yeah. Right. They're not huge, anyways. With Apache and a lot of dependencies getting pulled in. Cool. Right. What else? Well, so GitHub/containers. There's a bunch of different. How much time do I have left? 10 minutes? Yeah.
But you have time till there is no pizza. When pizza is there is
Yeah, yeah, that's cool. All right, so there's a bunch of different tools in there. So this is our kind of a container love child. And there's a bunch of different projects here. So Podman, I already showed you, Builda a little bit as well. And then there are some other stuff, like Scorpio, for example. That is sorry. Well, yeah, actually, something that I wanted to show you guys. So the man pages are really awesome for these things. So if you just do like man, Podman, or man Builda, etc., you will have then specific man pages on all the kind of stuff that you want to do. So, for example, if you're thinking about build, then you have a specific man page for that. Man, Podman, build. And then there is just a lot of stuff, including like, examples of how do you actually use these things. Because sometimes man pages are a bit for programmers of the project or something like that. But these are really awesome. And it's the same for all these tools. So for example, Scorpio also have like how was it that I used Scorpio inspect, for example. And then I have a lot of info on that. So I'm gonna show you Scorpio as well, because I think it's a neat tool. So it can do a bunch of different things. For example, inspecting images. So I think I can do like this. Yeah. So sometimes you're like, yeah, what kind of image tags is available for, something. Then you can use Scorpio for that. So it just goes through the container itself and spits out low-level stuff in general. If you have also like maybe a container that is exposing ports and stuff like that, and you're a bit unsure what kind of ports is it, or what kind of UID was it that this thing was running as, and so on. That is information that you get out of Scorpio. Really, really useful tool when you are kind of building stuff in the dark. Right. Then we have Podman Desktop, because there is something called Docker Desktop, and some people they do not like command lines, so this is then the tool that you can use, and it actually is available even on Windows and Mac and Linux. Yeah.
Podman is running in the container.
Well, this program is running.
Podman Desktop is one.
Podman Desktop.
Pull request coming.
Yes. Yeah. Absolutely. So here we can see the stuff which is running locally on this system, and we can, go into this, and we have integration to Scorpio, so we can get, the kind of inspection of this. We can, get a little terminal. We can generate kubeconfig out of this, and you can actually, as you have an image. So I don't have a cluster running here, but you can, if you've integrated to your kind of Kubernetes cluster, you can just click deploy to Kubernetes, and then it just takes your locally built image and whoop, swipes it away. So I haven't used Docker Desktop in years, so I don't know if this is a cool feature or not, but it's most definitely something that I use myself. Anyways. What else? Yeah, pods, right. You can create pods locally on using Podman. Well, it's in the name, I guess. So this, let's see, pod create, Foo Café, port, I think. Just see if it was my wife. Right, so now we have created the pod. So that you can do from the kind of GUI here, pull request. Right, so now we have a pod running here, and now we can attach containers to this. So, oh wait. HTTP, take a normal build. Podman build tag foo hpd ubi9 build. Okay, cool. So now that we have this running, oh, yeah, there we go. Then we can run it. Podman run name httpd pod demo. Demonize it. Pod. Foo Café pod. I think this should work. Yeah. So let's see. Curl localhost. What was it now? 8088. Yes. Okay. Also works. So useful if you have a bit more complicated like deployment scenarios and you want things to kind of, well, share a pod. Neat. So I think that was, yeah. So Podman Desktop itself. So as we have containers here, we can do, let's see, images. For example, we have and run image, maybe, for example. Local image, 8090, maybe. And generate name, Podman Desktop demo. There there we go. And we could add volumes here if you. That's something you can do. Just add v, and then you can map a local volume into that. We can actually try that. Well, it's so here's the running Podman Desktop demo was called. Curl localhost 8090. Yes, again. Cool. Right. So that's basically it. Neat kind of place, and you can obviously create volumes in advance, or you could do trying to make myself fail at some point. So let's if we do like this, then make container storage. No. We'll call that HTML echo Foo Café rules index.html, and then we run a container, and then we map that into the kind of web root of that. Should maybe run name new demo demonize pod 8099 to 80 volume. Where are we? Volume, and then that should go to var HTML, var ww HTML said. But now I remember I have to do something more. I don't think this works out of the box. We have to unshare the. Who knows the? What's the PID of Apache? The default PID of Apache. Come on, guys. Terminal. Where can we find that even? UID map? That's just one. Yeah, it's runs as root. Yeah, okay, yes, fine. Okay, so let's lie. Podman unshare schmod root HTML. Yeah, thanks. Okay, cool. So this should then work. And we called this. What did we call the container? We call it just UBI 9. Podman images. Yeah, it was this one. Okay, that did run. Podman curl and yeah, I need pizza also. Yeah, and that actually did not work. So why didn't that work? HTTPD UBI 9 exec Podman exec did I call it new demo? Aha. Yes, yes, I did. Yeah. That's weird. So I just seem to have pointed that wrong. Stop new demo. Podman RM new demo. And do this again. Aha, yes. Look at that. HTML. Yeah, okay. This should work. Curl. Yes. No, wait, that's the wrong port. Cheating. No, it did work. Okay, so as you can see, you can manage basically most things containerized. So manage, start them and stop them. And I didn't have time now. I'm running over a couple of minutes. Podman has also support, so it can generate systemd config for your containers. So instead, you can run the container as a service. And that might be a neat thing if you are running applications as containers without Kubernetes. And you can just check out Podman system. No. Yeah, no. Generate. Yes. So actually, yes, here is the man page for that. So we can. I mean, I don't see pizza now, so we can try.
Like 2-3 minutes for a question.
Yeah. Questions so far, just while I'm researching how to create this. Yeah.
You want to speak? Yes, can you?
Yeah.
Okay, thank you. I had 2 questions actually.
Yeah.
So first question, can I take an existing Docker file and just use that directly without making modifications?
Yeah.
Second question, does Podman support multi-stage builds? Multi-stage builds, so trying to build, taking one stage of a build and inserting it into another to now get your artifact.
Okay, so to your first question, yes, in most cases that will just work out of the box, yes. With just, you don't have to even rename it to container file, but you could do that. And your second question, I'm not sure I understood.
So multi-stage builds. So when you you take the output of one build and use that as an input for the second build.
Yes, you can also do that, yes. There are quite few scenarios that Podman or Builda could not handle that you could do and I think the only thing I can kind of come up with is how they do kind of container in container. But I would say don't do that. Anyways, it's just but you still can. More questions?
We give you one last question.
And for online people, if you can hear me, you get 1 minute to ask your question. Be quick, or the pizza is there. So.
Yeah.
Anyone have any more questions? No.
Then I will ask. So,
Yeah.
how good is it integrated with Mac system?
Yeah. I mean, I don't run Mac, so I can't really answer to that. But I mean, I have a lot of colleagues who runs Mac. they haven't complained.
And they use Podman Desktop as well in Mac.
No, so it's not. So most of me and my colleagues, we use mainly command lines. I can't say that. I did ask around in my team, kind of if someone on Mac were using Podman Desktop and experience in comparison to like Docker Desktop. And I had one colleague who were kind of using it on and off, and yeah. I mean, it's not a mega complicated piece of software, so it's yeah.
Hi. Do you have any other tips for minimizing the size of the containers? We basically showed two.
Yeah, I do. Okay. So my tip is, don't worry too much about that. Worry a lot about this. This is a visualization that I created of a container and how a container integrates to the system call interface of the Linux kernel. These blue dots, every blue dot is a unique ELF binary, and every orange dot is a unique function in the system call interface, where some of these kind of functions, they are, well, you can see kind of, what it's doing to things. So this should be more like what you are mainly concerned about, like how when your kernel is, moving in having kind of one life cycle, and your containers have another, and also that because of this relationship between these two, once you have containerized something, you can never stop patching. It never stop, because it stops working then. Because your standard C library inside of your container, which implements the system call interface of the kernel, will just at some point not match up. And then some from a customer of ours, so they deploy a new version of Grafana to their Kubernetes cluster, and then some weird a kernel bug in the XFS file system that no one ever saw before, makes all the file systems read-only on the node. So the node goes off. Kubernetes takes this new deployment, puts it on another node, it goes offline, takes it and puts it on that kind of stuff. Or silent failures of, security, for example. Really scary stuff. That is, I think, expensive, and I think a couple of extra megabytes, it doesn't matter most of the time. I think I have yet to see where it's, well, if only the container would have been 3 megabytes instead of 7, then we would have been fine. It never happens. Like, storage is cheap. And messing up things long term in your life cycle management is very expensive. So that is my advice. But scratch, create your own Linux.
Yeah, so it's cool. So how do you minimize this? Is just knowing what gets into your container, or write everything in C, or a small subset of C? Or
Well, the easiest way is to sync node and container. So rel, for example, and rel derivatives. If you didn't know, we have something in the Linux operating system called the ABI, the application binary interface, kind of the collective API for applications running in that Linux operating system. And that means that, running on rel or rel derivatives with like UBI base containers, for example, is really solid, tested, like massively tested, and then it's very rare that you would see anything strange. But you know, if you're not running glibc, you know, that affects how you do math. Don't do that. Run other stuff than glibc if you don't know what you're doing. And I only see standard C library maintainers know that. Anyways, yeah, cool. Yeah, this is how you, by the way, generate the if I do like this, boop, here I get the container file. So if I move really quickly here, config system D, oh, it already exists. Copy this into my users. Again, we hate running root, right? Config system D, and then I think I will just have to clean out, and then system control user daemon restart, reload. Thank you. System control user enable now. Unit file does not really.
Shall we call it the good DevOps?
Yes, okay.
Thank you.
Yes, okay. Well, I'm missing something there, but that would basically be, then you would add the, I messed up somehow, but it's that easy, and normally it just works as well. Right? Thank you.